So essentially, as you pointed out, I'm a physicist. I have an engineering background formally. However, I moved into the world of quantum physics and quantum computing fairly quickly after I graduated. For context, I was really deep into the AI side of things before I graduated engineering. I had worked at the biggest bank in Canada, working on AI, and I had filed a couple of patents for the bank as well. And so they had given me a return offer to join them the next year after I graduated. But here's the funny part. I became extra obsessed with quantum mechanics. Like, I was always reading about physics, learning, and I'd done lots of physics before my undergrad. But then I realized that there was something here that from just a philosophical standpoint and from the edge of science standpoint, that needed to be addressed. And it was far more exciting than just the normal engineering day-to-day life. So by the time I graduated, I was at a bit of a crossroads. Do I go deeper into physics, knowing that there's no direct impact necessarily to the world, right? There's so many problems that still need to be solved. And really, so like, do I do that, or do I work for, this big bank with a nice, comfortable job doing some really cool stuff on the AI side of things? And I ended up kind of, leaving that job fairly quickly. I left after 4 days to apply to the world's it was the world's first quantum computing incubator. It's an elite science incubator that generally only takes people with a master's and PhD in physics, but they were willing to make an exception for me. Part of what helped was I had quite the track record in the tech world anyways before this. So what I ended up doing was starting a company through this quantum computing incubator, and I was exposed to the world's best scientists. I still am, constantly surrounded by them. And what we did was my company sort of started focusing on the simulation side of things, because that's the biggest power of quantum computing that it really offers, is your ability to simulate nature, right? We can't do that with classical computers as well as we can with quantum computers. The problem, though, is that quantum computers are still nascent. So a lot of what us researchers have to do is we need to contribute to, based on the physics of the machines, how do we improve them? Because those are, they're very hard quantum computational problems, sure, but the actual underlying hardware requires huge advances in physics still, and that whole field needs support. So what I realized was that it's kind of like a positive feedback loop that we could create. We can use our current quantum computers with our current AI capabilities to help design better quantum computers and discover these new physics to create these new computers. So we're kind of like in this meta field, you can say, like what my company works on. At the same time, though, over the last year, I started reading more and more into the UFO sort of topic, especially because of what happened with AATIP. My mind was more open to it, actually much more. I would not have taken this seriously if it wasn't for those NY Times articles that come out. So yeah, after a while, I joined UFO Twitter, if there's a name for it. And that was amazing because there were so many conversations that we had where it was like, wait, this guy's right, or like, this was so cool to read. And that theory is definitely wrong. But, like, it was just a nice way of engaging and understanding. And I realized fairly quickly that this topic was underserved. It was not treated properly with the scientific rigor that it absolutely deserves. So, but of course, you got to keep in mind, if you put yourself in my shoes, I'm one of the few 20-year-olds that this incubator took a risk on, right? They've given me, like, my company was started off at a valuation of 1.7 million Canadian. And here I am starting to talk about UFOs. So it's been quite the journey. It's been difficult, but it's been worth it. So at the conference, what I want to talk about is what will a new world of science look like? How will our education system change, and how will the way we fundamentally do science change, and what will it bring us? So yeah, I think so, but I'm starting to realize it's less about the technology per se and more about the cultural change, because in the end of the day, this tech we will eventually figure out the tech too. Maybe not this century. Like if nobody helped us, right? I'm sure it would, in a couple centuries, we would also be developing our own UAPs to the level that we see them at. But I think it's more the fact that what we're seeing now is like a cultural acclimatization to like sort of like an awakening, especially for the science world, to realize that there's actually more than what meets the eye, and the fundamental nature reality is different. Like that's what I'm starting to realize, and so long as science ignores that, we're not going to get very far. We're just going to keep making these incremental additions to our chemical propulsion systems. We're going to be building better iPhones and laptops, but really, and maybe better computers, right? Quantum computers, but there's no current fundamental breakthroughs in physics. Every physicist knows this. We all complain about it. And I see why. Like, I think that the next breakthroughs will come from this topic. I think you're absolutely on point. It's this aspect of the phenomena that makes it so hard to study, right? It's A, not reproducible, and B, even when you, actually there's a saying, I forgot who told me, but there's a saying about it, and it's funny. And it's, the phenomena is repeatable, just not on your own dime, right? So it does repeat, just not when you want it to. And so that makes it hard. And also the fact that, like, if you look at how science tries to take a reductionist take on stuff like consciousness and the human experience, most of that is currently left to psychology. And the thing though is that our reality is still based on physics. It's still underneath the hood so far that we know of. It's still running on mathematical rules of logic. So there seems to be this weird disconnect between people's experiences and the spiritual side and the math. And so I understand why it's difficult to study. There certainly is. I think the biggest threat is actually AI bias, because every AI system right now has bias, and the bias comes from the underlying data sets that it was trained on. So for example, we have cases, I'll use one that's, it's very unfortunate. So there was a store somewhere in the States. They decided to use AI to predict which one of their products should have a glass enclosed case around them, right? And that AI product only picked the hair product that had like African Americans on it. And this is a direct result of AI bias, because it was trained on these biased data sets that the police were giving to them in some other places. So we need to worry about, eventually, once we start giving more power to them, we need to understand what their own biases are, and it reflects our biases as a society. But right now in the near future, that is our biggest concern, just like letting these rules get dictated, giving them to somebody that might not be objective, even if it's an AI. However, our real long-term worry is going to be, how will we preserve the human identity? Because it seems like that's going to be eradicated if we're not careful. And I think it will happen in our lifetimes. But obviously the question is a matter of when. But I don't think it's going to happen until we're spiritually prepared. I mean, we are so primitive. We can't even treat each other properly. Like, why would they expect us to treat them properly, right? Most people would just have their entire lives ruined if a giant alien spaceship showed up over the city, right? Like, it would be the end of the world, literally. And so long as that's true, we're never going to have open contact.